Hi there, my name is Hao, and this is just another video of me solving random LeetCode problems. So let's begin. So today we have the two-sum 2 problem. Input array is sorted. So it is a variation of the two-sum problem. So given an one index array of integer numbers, and the array is already sorted, we need to find a index 1 and index 2 where the value at these two index added up to a target, and index 1 and index 2 have to be unique, and we guarantee that there's exactly one solution, right? And most importantly, we need to do it in constant extra space, right? So in the previous two-sum problem, we used a hash map to keep track of the visited um, number, right? Which is why we were able to solve the problem in O of n. But here, since we need to do it in constant space, we cannot use the hash, right? Um, but instead, I think we can take advantage of the fact that the array is already sorted. So maybe we can do something with it. Okay, so let's look at the constraints here. So target in numbers can be anything, and then there will be at least two numbers. So we don't need to worry about the edge case where there's only 0 or 1 element, and the number is sorted, and we only have exactly one solution. So that is good. So let's look at the example here. We have 2, 7, 11, and 15, where the target is 9. And we see that the output here is 1 and 2, which is these two elements right here. The 2 and 7 added up to 9, right? And we return 1 and 2 because it is a one index array. So we need to add 1 to it. So 0 plus 1 is 1, and 1 plus 1 is 2. And we need to return it in this exact order because we have the constraints right here where the index 1 has to be less than the index 2. So that is another thing we need to think about. Okay, so I think if we can use two pointer to do this because we know for the fact that the array is sorted. So if the current sum is less than our target, we can move the left pointer to the right. We know that moving to the right, we will have larger number because the array is sorted. Similarly, if our current sum is more than the target, we can move the right pointer to the left because we know that the array is sorted. So moving the right pointer to the left, we will have a smaller sum, right? So we can start off by setting the left pointer at the first element and the right pointer as the last element, right? So our current sum now is 2 plus 15 is 17, right? And we know that 17 is greater than 9, so we want to move to the left, right? So right here, and then now the sum is 2 plus 11, which is 13, and 13 is greater than 9, so we need to keep moving left. R, so the sum now is 2 plus 7, which is 9, and we got our targets, right? So we just go ahead and return 0 plus 1, 1 plus 1, which is 1 and 2, right? Which is match our output right here. So using this approach, our time complexity will be O of n because the maximum step we have to do is O of n, right? So whenever the left pointer pass the right pointer, we will just stop the operation. But I think that would never happen because we guarantee that there will be at least one solution. For the slave complexity, we only have O of 1 because we only use two pointer here, two variable. So let's go ahead and code this up. So we have a left and the right pointer. So left equal to 0 and left right equal to inverse that length -1. And y left is smaller than right. And then we can do the current sum is equal to number as left plus the number as right. So if the sum is less than the target, then we want to move to the right side. So left plus. Else if the sum is greater than the target, we want to move to the left side. So right -1. Else we got our target, so we just go ahead and return left +1 and right +1. And that is it. Let's give it a try. Accept it, submit. And we are doing pretty well. Yeah, we beat 76% of JavaScript user for the memory, right? We could be using constant space. So thank you for watching.